Hi, good morning. This is Piran Kumar, Assistant Professor, Department of Computer Science. So today we're going to discuss about the architecture of 8257 and the DMA controller. So when you see about the architecture of 8257, so it has an 8-bit of a bus data. As we have already discussed that 8257 never services the interrupt. It simply forward the interrupts to the microprocessor. Thus, above architecture has the different units that combines functions to increase the interrupts handled by the processor. The following figure shows the architecture presentation of 8257 programmable interrupt controller. See this? The left side you have the data bus buffer and you have read write logic, cascade buffer comparator, and the right side you have the logical, that is control logic, and after that you have three separate part, that is in service register, that is we call it as an ISR, and we have a priority resolver, that is any interrupts receives from that interrupts. So which interrupts has to take over to the processor, that is going to be solved by the priority resolver. And the next one is the interrupt request register, that is IPR. So totally it has eight register over there for handling the different interrupts. And the below one you have the interrupt mask register, the IMR. So in between the left side and the right side, you will have something called the internal bus, where the bus system is going to take over there. So the data transfer is going to be takes over from the left to right using only within internal bus systems. And I come to the left side, you have the data lines, that is D0 to Z7, and you have the next middle one, the read write logic, that consists of read operation and write operation, and with the help of an address first line, that is A naught. And also you have a chip select called the CS. The cascading buffer, that is you have three lines over there, three pins we have, that is CAS naught, CAS1, CAS2, and also you have SP and AN enable. Okay, we'll see in detail about this. So let us understand the operation performed by the each units in the detail. The data bus buffer, that is the 8259, has a tri-stated bidirectional 8-bit bus buffer, that is D0 to D7, that interfaces with the internal buses of the processor. The 8085 microprocessor sends or receives the controls or the status words to or from the 8259 using a data bus buffers. In the case of the read write logic, this unit is responsible for controlling the internal read write operations of the system. It holds initialization commands, word registers, and operation commands, word registers inside which various control formats exist that are needed to be for the device operations. The RD, WR, AO, and CS are the pins that are associated with these units. Basically, these pins are used by the processor for read and write operations. The low signals at CS, that is chip select, shows that now the communication has been set up between the processor and 8257. The case of control logic, this unit is the heart of the architecture of 8257, that is, sorry, 8259. This controllers, this controls the all over operations of the system by sending the INTR signals to the processor whenever the interrupt request is generated. Also, it receives INTA, that is interrupt acknowledgement. We call INTA as an interrupt acknowledgement signals by the processor when the microprocessor demands for the address of the interrupt service routine. Then the fourth one is the interrupt request register, that IRR. This unit stores the interrupt requests generated by the peripheral devices. We know that the 8259 has 8 interrupt pins, that is IR0 to IR7, so it is going to handle up to 8 interrupts at a time. So the units can store 8 interrupts requests that are requesting the service from the microprocessor. And the priority resolver, this logic unit decides that among the entire interrupt request present in the IRR, which holds the highest priority and needs to be executed first, which is highest priority that is going to be executed first. Suppose at the time of servicing an interrupt, another interrupt is incoming, request gets generated, then the request will be ignored as a one end service. That is, when one particular interrupt is handled by the processor, so if any interrupt is coming in between that, so it will not respond that. So first it will execute whatever the in service is being there, and it will go to the highest priority, what is in that IRR. In the service register, here the number of units is itself indicated the operations performed by it. This register unit stores the interrupts which are usually currently being executed by the processor. The priority resolver sets each bit of ISR and after getting interrupts word command by the processor, the bits gets resets. The interrupt mask register. This registers with holds the masking bit of those interrupts which are to be masked. And though through the thorough operations word command, that is OCM, the processor sends a required operation and the program the interrupt the mask registers. Cascade or buffer comparator. As we have already discussed that by cascading the multiple 8259, the number of interrupts handled by 8259 can be expanded up to 64 bits. The units allows the comparisons of IDs of the different 8259s cascaded together. In the case of PCA operations, in the case of 8259, it permits the operations of the systems in two modes, that is the master and slave mode. In the master mode of an operation, it acts as a cascaded buffer, whereas in slave mode, the unit acts as a comparator. Among the various cascaded 8259, one 8259 directly handles the interrupts by forming a connection with the processor, and it is known to be the master 8259, while the other 8259 that interrupts the masters, and 8259 is also known as the slave of 8259. Each of the 8259s can be separately programmed as all of them hold a specific address. The cascading pins of the master 8259 CAS0, CAS1, and CAS2 forms a connection with the corresponding pins of the slave's 8259 PCs. For the slave devices, these pins act as an input pins, while for the master devices, these act as an output pins. An active low signals of the SP and EN as a device shows that it is operating in a slave mode. So this is in a diagram of the 8259 pin configurations. That is, you have 28 pins. The left side you have 14 pins, and right side you have 14 pins. So in general, what are the symbols we have? That is volt VCC, that is it is for 5 plus 5 voltage, and GND is nothing but a ground, and CS here is referred as a chip select for read write operation, and WR is nothing but a write, and RD is nothing but a read. So you have eight data lines, that is D0 to D7, that is a bidirectional data transfer bus, and you have three cascading lines, that is CA0, CAS0 to CAS2, and SP and EN, that is slave program, and other one is the enabled buffer. Okay, then the next one is INTR, referred as an interrupt, and you have eight interrupt requests. So IR0 to IR7, and INTA is nothing but an acknowledgement for an interrupt which has been accepted by the processor, and A naught is nothing but an address lines. A naught is nothing but an address lines. So advantage of 8259 PCs are the interrupt management. That is, 8259 PCs is designed to handle interrupts efficiently and effectively, allowing for faster and more reliable processing of interrupts in the systems. The flexibility, the 8259 PCs is programmable, meaning that it can be customized to suit the specific needs of the a given system, including the numbers and the types of the interrupts that needed to be managed. The compatibility, the 8259 PCs is compatible with a wide range of microprocessor, making it a choice for managing interrupts in many different systems. The multiple interrupts inputs, that is 8259 PCs can manage up to 8 interrupts inputs, allowing for the management of the complex systems with multiple devices. The ease of uses, the 8259 PCs includes a simple interface pins and registers, making it relatively easy to use and the programs. Disadvantages, that is, you have cost, limited number of interrupts, the complex programming, and the limited functionality. In the case of cost, does not have the add cost of a system, particularly if multiple PCIs are required. limited number of interrupts, that is, it can manage up to 8 interrupts at a time for insufficient for some applications. In the case of complex programming, it was relatively simple. The programming and can be complex required careful attention to your interrupt, prioritizations, and other parameters. In the case of limited functionality, it can be useful for the peripherals for the interrupt management. It does not include more advanced features such as DMA or the advanced error correction. Hope you all enjoyed the session. Thank you.